Okay, so here we know, because we're told in the problem, the total weight of the box filled with candles was 12 pounds. So I'm going to actually cross that out because I don't need it anymore. I've already identified that information. What's the weight of just the box? 3 pounds. The box weighed 3 pounds. Could you figure out the total weight of the candles? The total, not each candle, but the total. What is it? So think about what information we know. We know that the whole thing, like the box and all the candles together, are 12 pounds. We know that the box itself weighs 3 pounds. How could you figure out the weight of all the candles?
Divide 12 and 3.
Do you want to do it? Who agrees? Divide. 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 Okay. Divide. Anyone want to challenge that? And say, I think it might be something else.
You subtract it
Why would you subtract it?
because the box, it tells you weighs 3 pounds. So you subtract the box from the candle.
So if I know that this box, that's 3 pounds, and then once I put stuff in it, the weight changes to 12 pounds. How much should I put in order for the weight to go from 3 to 12? 9 pounds. Do we all see how we went from 3 to 9? So now I can use some other information. 9 pounds, I have 9 pounds total. That's a weird 9. And each one is 3/4 of a pound. How many are in there? What can I do? What operation? So I know that the total is 9 pounds, and each candle weighs 3/4 of a pound. So, I mean, I could sit here and draw them all out, but what could I do? What operation could I do to figure out how many of those 3/4 pound candles are in the total of 9? 3/4. So what you're thinking 3/4 times the number of candles is going to give me a total of 9. I can do this without writing an equation. That equation is correct. We're actually going to work on the equation next. With just the information you know, just the 9 pounds total, and each one. Think about what operation that is. Doesn't matter that it's a fraction. You have that total of 9 pounds. Each individual candle is 3/4. I don't know how many there are, but I need an operation with the 9 and the 3/4. That would tell me how many of those 3/4 are in the 9 total. What operation does that sound like? Sounds like what? What are you going to multiply?
9 into 3/4.
The 9 times the 3/4. Okay. Would anyone do it differently? So one of our suggestions is 9 times 3/4. Think about how many of these are in there. So think about the wording this way. If I take that 9 pounds and I break it up to 3/4, I would know how many candles there are. What operation is that? Yeah, I could divide. Okay? If I divide, I'm going to take this 9, I'm going to divide it by the 3/4 so that I'm figuring out how many 3/4 are in 9. Could you tell me how many 3/4 are in 9? Without doing a crazy calculation? How would you figure that out mentally? How many 3/4 go into 9 wholes? Is there anything you know about 3/4 going to like a whole number? I could separate the 9. What do you know?
3 goes from 9 3 times.
Okay, so I know that of my 9, how does that help you? What do I know about 3? How many 3/4 are in 3? How many 3, now think about this, how many 75 cents are in $3? What do I have if I have 2 3/4? How many quarters do I have? I have 1 and 2/4. Good. Add another 3/4. Okay, add another 3/4. Right, which is 3 wholes. Okay, if I break this up, okay, and I know that a lot of you look at fractions and you just shut off. You like look away. Most of you aren't even looking up here. But this is a realistic operation. How do I do 9 divided by 3/4? I don't even need to model this out, right? Even though you should understand that 3/4 goes into 3 wholes 4 times. 3/4 and 3/4. So think about this. 75 cents and 75 cents is $1.50. Another $1.50, that's $3. That's 4 of them. Okay? If I did this operation, we're not even talking modeling at this point. We're just talking about dividing a fraction. How do you divide a fraction? What do?
You change it into a multiplication.
You change it to multiplication. How? You're right. Change it to multiplication. You have the right idea. What are you? 9 divided by 3/4 is the same as what?
9 times 4.
9 times
4 thirds.
4/3. What's 9 times 4?
60. No, 36.
9 times 4 is 36. 36 thirds. Can I represent that a different way? How many times does 3 go into 36? 12. Good, Marilyn. So our answer is 12. There's 12 candles in the box. Okay? However you choose to break it up is your choice. If you choose to divide here, that's fine, especially at this point in your mathematical career. You've learned how to just simply multiply or divide fractions. Okay? And I know when you see fractions, a lot of you just freak out. There's no reason. The operations are straightforward. You spent a good amount of time in 6th grade and 7th grade modeling why these operations work. You're at a point in 8th grade where you don't need to explain to me why these operations work. You need to know how to just do the operation. In 8th grade, we work towards what we call fluency, meaning you can quickly do these multiplication or division problems. So if we wanted to write an equation, and Giovanni, you started to guide us through that, we could write an equation to represent this scenario. Okay? The weight of 1 candle, which is 3/4 of a pound, times the number of candles, which we don't know, so we'll say it's C, plus the weight of the box will equal 12. So my equation here, the candles, or the weight of the candles, plus the weight of the box equals the total weight of the candles and the box. How would I solve that equation? Just the steps of an equation. What would I do first? Just like you did in the warm-up. What would I do first? What did you choose to do first? We have to get C by itself. I can subtract 3 from both sides. So now I have 3/4 C equals 9. And now what's the last thing I have to do to get rid of the, to get the C by itself?
Divide.
Divide by? Divide by 3/4, good. And the reason I'm dividing by 3/4, it doesn't matter if it's a fraction or a decimal. Whatever is happening to my variable, inverse operation. So now, any number divided by itself is 1. So I have C equals 9 divided by 3/4, which Marco pointed out is the same as 9 times 4/3. We still get an answer of 12. The fact that it's a fraction doesn't change anything. You're still identifying inverse operations and undoing them. And my goal, hopefully, for the end of the year is that when you see a fraction that you don't panic, you just do the operation. I promise you, the more you try to work with those operations, just multiplying fractions, dividing fractions is multiplying the reciprocal. The more you do that, the more comfortable you're going to get, and there will be a point in time where it won't seem odd to you. I struggle more with decimal. I hate working with decimals. But fractions are straightforward once you understand just the process. That this becomes this. So we already answered these questions as we went, so I'm going to skip it just a little bit. We actually answered all of this. So with your group, in your table, and this is the time where we need to actually talk with just the people near you, so it's not a crazy conversation, about how you're going to solve this question. 2/3 x plus 1 equals 5. You're solving for x. Now, you may choose to do it in your notebook first, and then share your answer, or at least maybe what you think you've got, with the people that you're next to. So it's not a whole class conversation, it's just the people that you're with. 2/3 x plus 1 equals 5. Oscar, head off the desk. When you think that your group has an answer after you've confirmed that everyone agrees, then we'll start to pull it back in. Good. So, that's all. Good, you're at a good point. You're one step away from being done. Get the variable by itself, no matter what it takes. So that you can do that calculation and find the second answer. Yes, that's it. Okay, so what's the last thing you have to do to x? Perfect. So now, the next thing, to keep it really nice and clear, rewrite what you have. Over here you have 4, and over here this time you just have 2/3 x. Now, treat this like a new equation. What would you do to get x by itself? Yes. So now what you want to do is that calculation. You can do it separate. That divided by that is the same as about multiplying reciprocals and dividing fractions. Yes. Yeah. So you're saying the same thing. 4 divided by 2/3 is the same as 4. What operation? Yep. So 4 divided by 2/3 is the same as 4 times 3. So now we can simplify that. How can we get that variable alone? Two things we need to do to get our variable by itself, because there's two things happening to it. Oh, never mind. Make sure you should. Fraction raising. is the same as yeah. Divide the fraction is the same as so if you know how to multiply a fraction, you know how to divide a fraction because it's the same thing, but you're multiplying it. And if you count by 2/3, you can see there are 6 2/3 and 2/3.
Oh, yeah.
Isn't okay, what's the first thing I can do to X by itself? There's two things happening.
Oh, you expect it to stay okay. This is not even half.
What can we do first?
You can
Now we have 2/3 equals.
I think you can notice that.
Now what do I do to get rid of 2/3? Divide
Well, you're
by.
right in front of me.
You want to divide by 2/3? Think about what's happening to x. We need x alone.
so like how many? How many what?
How do I get rid of this? So now it's alone. But I have to do a little bit more separate. I'm gonna rewrite this because I feel more comfortable writing my fraction this way. 4 divided by 2/3. 4 divided by 2/3. So we multiply the Okay, let's take a look at this problem. Some of you, you're number one, you're doing a good job identifying what's happening to the variable. That's key. First thing. We want to be able to look at that, and even though it's a fraction, we want to be able to say our variable is being multiplied by 2/3, and we're adding 1 to it. Okay? If you can identify that, you're at a good point. From there, we know that once those operations are happening, I have to undo them to get x by itself. So the first thing, and we saw a lot of you do this, a lot of you took away 1 to begin. When we do these equations, we tend to like to get rid of those constants first. You don't have to, but that's what we like to do. So now I have, notice how I rewrote the equation. Okay, this is a strategy for those of you who are still learning how to solve equations. Instead of just putting -1 and a 4 here, like you can rewrite the whole equation because now you're treating it as if it were a totally different equation. So now you're going to the next step.
And can I just interject? Some of you are a little confused. Maybe your last teachers haven't taught you this and just assumed you knew it. Any number that's next to x like that means it's being multiplied by it. Okay? Because sometimes you would see the dot in between or an x. Now if you just put the number next to a variable, a number next to a variable always means being multiplied. Okay?
Because think about this number. That means 3 of a number. 3 of any number. So say my number was 2. That would be 2 and 2 and 2. That repeated addition is multiplication. So now, how do I get rid of, or how do I get the x by itself? What operation? You're saying the process? What operation, Jared? I'm going to divide. So here, x is being multiplied by 2/3. So I'm going to divide. The reason I use this symbol, I use fraction symbol to show division here. The reason being, I know that any number divided by itself or any number over itself in a fraction is 1. It doesn't matter if that's a fraction, a decimal, or even an irrational number. Any number divided by itself is 1 whole. So that means after I do this, I can just erase here because I have a 1. So now x is by itself. What I need to focus on is the other side of the equation because I don't want to leave it like that. That operation tells me that I'm doing 4 divided by 2/3. And here, a lot of you, and Mary, we were talking about it in the back, like, dividing fractions is hard, right? Who here likes to if you had a choice in operation, you had, no matter what, you had to do one of the following. You had to add fractions, subtract fractions, multiply fractions, or divide fractions. Who would add fractions if that was like the one operation you had to do? That's your favorite thing to do with fractions. Who would subtract fractions? Okay. Who would multiply fractions? If you had to choose one operation that you had to do with fractions. Most students would say multiply. So for those of you that say multiply, you're in luck because dividing fractions is a form of multiplication. 4 divided by 2/3 is the same as 4 times 3/2. So you just took that division problem and turned it into multiplication. Now if I calculate this, what do I get?
12.
I get 12 over 2, which simplifies to 6. So then here I can actually just change this out. X is 6. We're going to work more on dividing fractions because it's one of those things where you'll realize as you go through that it's not as hard as you may be making it. You already have the skills to do it. We just want to show you how to do that at your own speed, at your own pace. Okay. So here's what we're going to do for our DOL. It's not going to be a calculation. And I want you to think as you answer this to how we try to guide you through an equation problem. So let's just give an example here of this. If you were to explain to someone how to solve that equation, how would you explain that? Now again, you don't have to just explain the steps of solving that one. That's just an example. But how would you explain any equation? Like what do we do when we solve an equation? What's the point? What's the purpose? What's our goal? Okay. So you're going to write in a few sentences on your DOL sheet how you would explain that. Pretend like you have a classmate who has never seen that before. How would you guide them through? We're going to take about 6 minutes. Once we finish this, when you finish your DOL, and you can put on your DOL sheet, it can go in the bin. Once you finish your DOL, we're going to hand you this worksheet. Tomorrow we are doing a lesson. It's like a full class group lesson. Okay? It's like an activity. The difference is we need this information in order to create the activity. Okay? So you're going to complete this worksheet. It's actually really similar to what we're doing. Okay? So you're going to complete this worksheet after the DOL. So once you put your DOL in, I'm going to put this next to the bin. You take one. Yep. For some of you, it might be the first time you've been asked to explain something in math. Just try to summarize how you would do that problem. You don't actually have to calculate it.
You want it to be in general, though. Like in general, it could work for any problem, not just that one. That's just an example.
if you're having trouble with writing, try to solve the equation and then just summarize in a few sentences how you did that. It's a good way to get comfortable explaining things in math. Grab that worksheet. It's next to the DOL bin. Why are you grabbing scissors?
Oh, for the,
No, you gotta do the worksheet first. Really? Not for this one, no. But if they're not doing anything, we need to kind of be like, do something.
Yeah.
Mhm.